In this video, I'm going to cover a topic that I get asked more than any other topic when it comes to resin 3D printing. And that is, what do the resin profile settings do? How do they affect my print? What does TSMC mean? And no, it's not a chip manufacturer. And whether or not you've been 3D printing for 2 years, or you just barely got your first 3D printer, I think you're going to learn something in this one. So first off, why do I have all of these resins here on my desk? And yes, it took a long time to put them all here. Each one of these is unique, and I wanted to show off the fact that each one of these I've calibrated and printed on several printers. The point of that is just to kind of give you an idea of where I come from on experience. I'm still learning. There's a lot of information, a lot of room to grow, so please don't take this video as like the gospel truth. There's lots of room for discussion and lots of more education that I need to learn from the community, and I think we can learn together. And so with that kind of established, let's dig into the meat of this video. And before I show the settings and start explaining them, there's a couple more things that we need to talk about. One, there are two basic types of 3D printers out there. There's Anycubic that basically makes their own motherboards, and they have different settings. And then there's printers that use Chitu Systems motherboards. That's going to be like your Frozen, your Elegoo, Uniformation, Apex, and quite a few others use Chitu System motherboards. The settings are almost the same, but there's some that are different. And so with that, we want to make sure that you can identify which printer you have, and so you know which settings apply to you specifically. I also think it's important to point out a pattern that I've noticed. After calibrating this much resin times 3, I've noticed a pattern. And the pattern is that most of the resins, especially your like fast ABS-like, they use 90-95% of the exact same settings across the board on almost all printers across the board. There are a few resins that I've tokened as specialty resins. These resins are like engineering grade, like maybe this Formlabs, basically primed to print rubber, like this EML 400 from Frozen, or this incredibly high accurate resin, the M70, or this really crazy stuff from Loctite. These are specialty resins, and there's a couple of them in here. But most of you will probably never come across these specialty resins. They're very unique in the way they work, and generally you're after some pretty crazy properties to use those ones. For these ones, use what the manufacturer has on the website. But for everything else, this video is going to cover these completely. So with that, let's get going. All right, how do I do this? Let's just try to move these over. Whew. All right. Just a big old resin hug. Now, if you're new to Lychee Slicer, when you first open it, you're gonna have to add in a printer. So for that, just click on 3D printer in the top left. Click on add right here in the green. I've got a lot in here already, just pretend that I don't. And you're gonna click on resin. This is a video about resin 3D printing. I'm gonna add in a printer I don't have yet. Let's see about Apex Maker X1. All right, now from here, when you first add in a printer, it's gonna add in a default resin. This is because the way Lychee works, you can't have a 3D printer without resin. They're tied together. But you really don't want to use this one. You can come in here and you can edit it, but we don't want to do that. What we want to do is we want to add in a new resin. So you're going to click on here, add new resin. This is going to open up the Lychee community profile resin. This video isn't about that one, so we're going to skip over this. And I'm just going to click on add new resin. Now from here, I can pick the brand. Let's do the RPG resin and gray. Now the RPG is coming in a few new colors. We haven't added them yet, but you can always click on add if you say, they're coming out with like a red, and you can do what you want here. And then you can make something like a little note for yourself for your resin. Sometimes I've seen people use this to say like how long they exposure it. For me, I just do boxes because I calibrate everything to boxes. But you can put whatever you want there. It's just a little comment to help you memorize it. So now that we're here, we're looking at this one. This is what a resin profile looks like for a printer with a Chitu Systems motherboard. I talked about that in a little bit. And real quick, I want to show you what it looks like for a Anycubic motherboard. But first, let's point out what you're going to see that's different. On this one, I've got these two tabs right here under global parameters. I can set this TSMC, and I'll explain that a little bit, on or off, and you'll see that some settings go away. Or I can set light on, delay on or off. Again, I'm going to explain this in a little bit, but you're only going to see these triggers on a 3D printer that uses a Chitu Systems motherboard. And I said that's most everything outside of Anycubic. But for now, the way I recommend using this is with TSMC on and light off, delay off. Now, what you don't want to do is have them both on. Having these both on right here, it triggers a bug in Chitu Systems motherboard, and some of the settings might not apply properly during the print. So you can either have them both off, or you can have one of them on, but not both of them on. So for this one, we're just going to do on, off, and hit OK. Now I want to show you what an Anycubic motherboard looks like. Let's take a look at the M3 Premium, one of my all-time favorites. You see I've got lots of resins I've used for this particular one. If I just open this one up, you'll see it's a little different. I don't have that global parameters on off at the top. I have light off delay as my only option, and I'm missing some settings here as well. One of the settings I'm missing is Retract Distance. I have Retract Speeds, but I don't have Retract Distance. So let's start with the Anycubic. We'll kind of explain what this means, and we'll move on to the Chitu systems because it's a little bit more complex. So starting at the top left, let's talk about burn-in layers. So burn-in layers, these are the first layers that are going to be 3D printed, the ones that are closest to the LCD. And in here, you set how many burn-in layers are going to be applied. So which means all the settings on the left column, burn-in layers, those are only going to apply to the first 4 settings in this profile. If I turn that number up, it'll apply to more. But in my experience, we don't really need more than 4. The second thing is the exposure time for the burn-in layers. Now the burn-in layers need a lot more exposure time because that's where the print is going to hold on to the build plate. And not enough exposure time and the print may fail to hold on to the build plate. What I see all over the internet is a particular comment, which I'm not a huge fan of, and it is my print stuck to the release film or to the FEP. I don't like that because it puts the blame on the wrong side. What I think you should say, the print failed to hold on to the build plate. And that way it kind of gives that idea that we're looking in the right thing to fix that. And this is where you're going to fix it, in the burn-in layers. So the UV exposure time, this 124, is only going to apply to the very first 4 layers. The next thing is transition layers. Now the transition layers is where we're going to slowly go from 24 seconds under the burn-in layers over to the, in this particular instance, 1.1 seconds, which is really low. This is a fast resin on a powerful printer. It's going to slowly transition between 24 and 1.1 seconds, and it's going to do that over 3 layers. This just kind of helps with, well, resin doesn't like to cure to resin that's fully cured. So if I were to take a resin that's completely cured and pour resin on it and cure it, it will hold, but you can separate it. It doesn't hold as well. And because these burn layers are exposing for 24 seconds, that's a lot of time. If we were to go straight from 24 seconds to 1.1, that bond wouldn't be very good. So putting a few transition layers can kind of help glue everything together and just get a better adhesion for those first layers. Next, we have lift distance. Now on the burn-in layers, your lift distance needs to be higher than on the normal layers. And this is because the longer you expose resin, the more it's going to stick to everything, including the release film. So we need to lift a little bit higher, just in case it's a little bit too sticky and it doesn't like to release. And so with that, let's talk about TSMC, because that's where this comes into play. TSMC stands for two-stage motion control. Two-stage motion control. What that means is the motion is controlled in 2 stages, a first stage and a second stage, hence the 2. The first stage here is notated by this 4 on the left. And this little symbol right here, the greater than sign, could be read as and then. So what this is going to do, it's going to lift 4 millimeters, and then it's going to lift an additional 4 millimeters, a total of 8 millimeters, which means for the first 4 layers, this is going to go up by a total of 8 millimeters, 4 and then 4, and then it's going to come down a total of 8 millimeters because what goes up must come down. A travel distance of total of 16 millimeters per a layer. So you can see if I crank that number up really, really high, the more your printer has to lift up and down, the longer the print's going to take. So we don't want to get crazy with these numbers. And what I've noticed is that 4 and 4 works for pretty much any resin on any 10-inch printer, which is your average size printer. Most people aren't using 13 or 17-inch printers, but if you are using a 13 or 17-inch printer like the M7 Max or the GK3 Ultra, add an additional 2 millimeters. So maybe you do 4 and 6. I wouldn't do 5 and 5, I'd do 4 and 6, and I'll explain that why later in coming up. And that gets us to the next thing, lift speed. You'll see that there's actual 2 stages for lift speed as well, 40 and 100. Now the left columns, being the 4, 40, and 100, are actually all tied together. And the right columns, the 4, 160, they're all tied together as well. So let me kind of read this out to you like maybe like a story problem. For the first 4 layers, this is going to lift 4 millimeters at 40 millimeters a minute. It is then going to lift an additional 4 millimeters at 100 millimeters a minute. So it's going to speed up. Then when it comes back down, it's going to start coming back down at 100 millimeters a minute. And then as it gets closer to the bottom, it's going to slow down for the last 4 millimeters at 60 millimeters a minute. So it's 2 stages. It's going to go slow, it's going to go fast, And then when it comes back down, it's going to go fast and then it's going to go slow. The reason for that being, the closer we are to the release film or the ACF, the slower we want to go. The reason for that being is that, well, resin has weight and releasing from the film has peel force, and pushing a print through a vat of resin has fluid dynamics. So there's a lot going on here as far as, gravity, fluid dynamics, peel force, and suction force. I'm not going to get too much into that in this video, but all that's happening, which is why we want to go a little bit slower the closer we are to the release film. And that's the advantage of TSMC. It allows you to go slow where it matters, but fast where it doesn't. Well, some might say, why not just go 4 millimeters up, 4 millimeters down at the slower speed? Why go the full 8? Well, the reason for that being is that it's true that probably most of the layers will release at 4 millimeters under the slower speed. However, the chance of some of the layers being really sticky and not releasing fully is pretty high. So the extra 4 millimeters is really insurance, just to make sure that everything releases from the film so we don't get a failed print. And that's also why we go faster. We want insurance, but we don't want to pay a lot for it. We like cheap insurance that covers us, and that's what that is. On the burn-in layers, there's only 4 of them. Don't rush them. They're incredibly important. If those fail, your entire print fails. Everything fails. It's a big waste of time. So that one I say, never, ever, ever go faster than 100 millimeters a minute on the burn-in layers. There's no advantage to speeding these up, and there's only tons of advantages to slowing them down. In fact, what you might want to do is even make this really slow on the retract speed. So as we get really, really low, we slow down a lot and really give time for that printer to come down and become more square. These ones I run very, very slow. Even if I'm running very, very fast settings on the normal layers, I'm still running my burn-in layers really slow just because, well, that's success or failure. It's very important. And so moving over to normal layers, we have layer thickness. Now layer thickness is how thick that's going to be sliced up. If you know what 3D printing is, you're taking a 3D object and you're slicing it like a bunch of papers. And how thick each one of those papers is the layers, the layer thickness. Now 0.03 millimeters is probably the lowest I would ever recommend going. That's not because the printers can't go lower. Pretty much every 3D printer on the market can go to 0.001. However, the resins, they can't. This is where you get into PSI. You try to squish a thick viscous resin down to 0.001 millimeters. It doesn't want to do it. It can be done, but I'll tell you about what you need to do if you want to print something that low, which is why 0.03 is probably the lowest I would go, 0.05 being the most used out there. The difference between layer thickness, I'd say 0.03 and 0.05, is if you're doing like minis, you're really going to get in there and paint, you might want to use 0.03 because there's going to be less stepping, just a little higher quality and detail, and that will be noticeable if you are someone who really loves the very best quality and you really spend a lot of time painting more than you do printing. The next thing is light off delay. Now light off delay is like S tier. This is probably one of the most important settings here. And this is why. So this might be new to a lot of people, even if you've been printing for a long time. When the motor stops spinning, and there's a motor that spins on the Resin 3D printer that moves the build plate up and down. When the motor stops spinning, the printer isn't done moving. The printers are, well, they're not $20,000, and so they're not necessarily the most rigid things out there. They're going to bend and warp and move. The LCD is going to push down into the frame. The LCD is going to warp, and the arm on the build plate is going to bend a little bit. So when that motor stops spinning, that printer is going to come to square as it squishes that resin. And the thinner the layer thickness, so let's say 0.001, the harder it's going to be for that printer to come down to square. And then the next thing is the resin must stop flowing. So until the printer stops moving, the resin will be flowing a little bit. And if you cure resin that's flowing, your accuracy is going to go to trash. Now 2 seconds is about the sweet spot for most resins on a 10-inch printer. It's where there's like a bell curve where it starts, the printer really comes to square really, really fast, and then it starts to kind of slow down towards the end. And so the waiting more than 2 seconds for most resins is diminishing returns because it really increases the print time. If you're using a very, very thick resin, you might need to go up to 3, or if you're using a really big printer or a printer that has more bendy than others, you might want to use 3 as well. Or something like the Saturn 4 Ultra where the entire vat moves. The resin's moving around so much in that it takes a while for it to settle down. On that particular printer, you're going to want to use about 3 seconds as well. The next thing is the exposure time. Now the exposure time is very much related to the layer thickness. The thinner the layer, the less exposure time you need per layer because the UV light doesn't need to penetrate and cure as much resin. This is something that you're going to have to calibrate for. This is one of those settings that you could copy from somebody, but because your printer might not be exactly the same, the temperature in your room might be slightly different, your exposure time might be 1 or 2, 0.1 or 0.2 seconds off from theirs if you have the same printer, same resin, even the same temperature. So that's where you have to calibrate for. Lift distance, this is the same as the burn-in layers, except for this is applying only to the normal layers. It's the same thing. On this one, we're going 3 millimeters and then additional 3 millimeters, a total of 6. The reason why we're not lifting as high on the normal layers is because they're not being exposed for as long. Remember I told you the longer you expose resin, the more it's going to stick to stuff, including the release film. This is exposing for such a small amount of time, 1.1 seconds, which I'll say is very low. Most of these resins here at 0.03 millimeters or 30 if I switch this to 30 is going to be about 1.8 on almost all resins. I found that to be very, very across the board, 1.8. And we don't need as much lift, so that 3 plus 3, a total of 6, is more than adequate. Now, if you want to risk it and maybe, move these down a little bit to like 2 and 2, a total of 4, you're welcome to try. But if you start seeing failures, come back here and add 3, 3. The advantages of not lifting as high is just gaining some print speed. But I've not found pretty much any resin on any printer within that 10-inch to need more than 3 and 3 or a total of 6 millimeters. Second thing is lift speed. 45 millimeters per minute I've found to be like a very safe. You're in the green zone right over here. Green zone is a place where pretty much any resin will print at 45 millimeters per minute beautifully. But it doesn't mean you can't push it. As you get more experienced and as you have like really high success rate, let's say you've printed 10 bottles of resin, you've had maybe like 1 failure across the whole time, you're very comfortable with it. You can start to push that if you want to gain a little more speed. What I would do is go from 45 is safe, 100 is starting to push it. Anything beyond 100 millimeters per minute on the first stage, you're getting into the red zone. But I would say 100, you're probably in the yellow zone, and anything under 60, you're in the green zone. And that's for the first stage. For the second stage, that's kind of what I talked about earlier, where most layers will be released from the film for the first 3 millimeters. This second 3 millimeters is mostly insurance. And the layers that tend to stick are really thick layers with really big cross sections. What that means is we can go fast because the odds of damaging these layers are relatively low unless you have suction cups, but I won't get into that in this video. I've got another video on hollowing and suction cups on the Lychee channel, so go ahead and check that out. And while you're at it, make sure to like and subscribe to this video. So on this one, because most of the smaller layers have already released, we can actually go fast on this one. I would say this is the one setting that there is no speed limit to. Most 3D printers have a maximum speed limit of about 450 millimeters per minute. Some of them go up to like 600. I haven't found any that go beyond 600, but I don't have them all. And I haven't been able to test them all. It takes some time to figure that out. But over here, you can go pretty fast. For me, I still like to keep it, around 250 to 300. More testing, honestly, on my part, would be needed to like just test all these at different speeds. It's a lot of time and effort, so I haven't quite done that one yet. Like I said, there's a lot I have yet to learn. But I found this right here is safe. We're in the safe zone. I would say if you're going up to 450, you're probably, you might be in the yellow zone, honestly. I don't know if there is a red zone for this particular setting. Now, coming back down on the retract speed, this 180, you'll notice that's a little slower than the other one. The reason for this being is retraction is a little bit different. You have to envision that you've got this plate with your print on it. And your print, you don't know where, it's always going to print really thin layers that are going to be suspended by all these supports. And so if you're pushing that print down into the resin, all the way down to that release film, a hard surface that's going to have pressure and resist that movement, if you're doing it really fast, the odds of things tearing, shifting, moving, warping actually go up quite a bit. So I would say on the retract speed, there is a speed limit. And I find that speed limit, the green zone, to be about under 200, the yellow zone to be probably around 200 to 250, and the red zone to be anything above 250. The red zone being, do it at your own risk, test it out, see if it works for you. On the retract speed, for the second stage, this is as your print comes closer and closer to that release film. Again, we're going to slow down quite a bit more, but not as much as we do on the burn-in layers. The reason for this is that I've played with this going really, really slow, and anything lower than 60, I haven't seen an increase of failure at all. but above 60, I start to see more warping and more issues. So I found that pretty much again for all these resins on almost all 3D printers, that 60 is in the kind of the green zone. But I've noticed about once you get to like 80 or 100, you start getting in the yellow, and anything above 100, you start getting into the red. Again, more testing is needed on more resins to confirm whether that's always true, but in my experience, that's what I found to be relatively true. Now for the other settings here, we don't really need to talk about these ones, but while I'm here, let's talk about this one, print time override. Now, these settings right here, these lift distance, lift speeds, the printers, they don't exactly always do these exact movements. They do close to these movements. The motor doesn't always spin exactly, the build plate doesn't always move exactly, and there's ramp up speeds and ramp down speeds. And so the print time override is to help you figure out, why do my print time estimates not match reality? Well, it's because the printer doesn't match reality. No printer actually moves at the proper speed that the profile says it. It's physically actually impossible. And so what you do here is you time your burn-in layers. So you'll sit there with a stopwatch and you'll time the first 4 layers. You'll average it out. You'll put in how many seconds it took per layer. And when it comes to the normal layers, so maybe you wait till like layer 10 on this one to get past the burn-in and the transition, you'll probably count, time how long it takes for the printer to do a full layer. That's, up, down, cure. You'll time it, you'll average it out, maybe 4 or 5, and you'll put that value there. If you do that, as long as you don't change your settings up here, your print time estimates will actually be accurate instead of really, really far off, which they're going to be if you don't use this setting at all. Again, that's because Lychee we can't actually tell you what the printer's doing, especially on something like a Chitu box motherboard. They've got some special things built in as well that actually change some of the settings from the slicer. And there's no way to override it, it's built into the motherboard. A lot of those settings are nice, they're helpful. They're kind of under the hood things that they do, and it's different for every printer. So yeah, print time override just helps you simply understand how to get your 3D printing estimates exactly. Now let's move over to a printer with Chitu Systems motherboard. There's one important thing to note, and that is not all of them have this global parameters toggle. For example, the Revo, which is using a newer version of the Chitu Systems motherboard, doesn't have that, which pretty much means the settings that I say to use are baked in. It always uses those settings, which are the best settings anyway, so there you go. And so really the big difference here is what we don't have is a setting called light off delay. You'll see it's missing here. That was that 2 seconds. Instead we have wait before print. And we've got one here in the burn-in layers and one here in the normal layers. Now this is a little bit deceiving because the way that the Chitu Systems motherboards work is they always read the wait before print from the normal layers. This right here, this only works under certain circumstances, and I'll tell you when it works and when it doesn't. But for most of the time, this 20 seconds, it won't be applied. It will always read the 2.2 from the normal layers. But wait before print is the exact same thing as light off delay that we found on the Anycubic system. They're the same. Wait after print, what this does is it's going to go down, expose the layer, and then it's going to wait until it lifts. Personally, I found that it waiting to lift actually increases the forces and doesn't decrease them. And so putting time in there can negatively impact your print. I've seen a few people say that actually waiting a little bit of time allows the resin to fully form before you lift. I personally haven't tested that or seen it, and so I don't know if that's true, and it could be true. I haven't tested for it. I don't really know how to, but it could be, say, like putting 0.5 seconds in there could actually, if it allows just that little bit of time for the resin to like fully kind of form and finish curing before you start lifting, I could see how that could be valuable. Wait after lift, this is if the printer's going up and it's going to stop at the very apex before it starts coming back down. I haven't seen any value in this whatsoever. My recommendation for this is leave it at 0. And again, the wait before print, this is where that printer goes down and it's going to wait for everything to come to square before it turns on. Light intensity, this is something that we see a lot on not every single motherboard that Chitu system. It's really based on the vendor being like Apex or Uniformation or Frozen. They get to kind of choose how they utilize the motherboard. So some of them have light intensity, some of them don't. This just allows you to turn down the UV light. You might want to do this if you have a resin that cures really, really fast, like a fast resin, and you want to slow down its cure so you have a little bit more control over the exposure time. So you can get a little bit more accurate, a little more dialed in. The other thing that's different is we have Retract Distance. This is a setting we didn't have on the Anycubic as well. This just allows us to tell us at what point does the 60 millimeters, when we're going back down, kick in. For me, I like it to go most of the travel time under the 200 and then only slow down to that 60 millimeter for the last 2 millimeters. There's really no point in going down very, very, very slow. It's gonna take a long time. We can go kind of quick until we get closer to that LCD and then slow it down again. And this is gonna allow us to actually overwrite that. So it's not just 2 and 3 or maybe 3 and 3 for this one. And you can notice you can't change the 4 here. That's because it's always has to be 6. So if I put 1 here, this will change to 5. I always just do 2, that last 2 millimeters to slow it down. I found that to be the safe zone. Now earlier I talked about where the wait before print or these wait times actually apply under the burn-in layers versus always using the number from the normal layers. And let's talk about that. So if I go and choose, let's say something like the Saturn III Ultra, and I go to export, you're gonna see a thing here where I can change the slicing format, .goo or .ctb. .ctb is the file format that Chitu uses, and .goo is specific to Elegoo printers. Now the advantage of .goo or .goo is they actually allow you to use a separate light-off delay for the burn-in layers than the normal layers. These things are read independently. So you can crank this up to 20 or 40, which is very, very helpful for the burn-in layers to have a very long light-off delay, and have a separate one. In this one I've got 3 seconds for the normal layers. The only disadvantages to .goo is that you don't want to use it with anti-aliasing. There's some major bugs with that one. So if you're going to use .goo, don't use anti-aliasing, even if the advantage of that extra light-off delay on the burn-in layers seems very tempting. If you're going to use anti-aliasing, you're going to want to use .ctb. There's 2 printers that are very different. That's the Saturn IV Ultra and the Mars 5 Ultra. And that's because these printers, they don't have a build plate that lifts up and down like normal printers. Instead, they have a vat that tilts. And even though they're using a Chitu Systems motherboard, you'll see there's a lot less settings here. And that's because there is no lift height or lift speed. That's completely done on the printer with the vat. And the only setting you can do is on the printer set whether you want normal or fast speeds. On those ones, I have found a lot of issues with the fast speeds, a lot more failures, a lot more layer separation. So on those, I do recommend using the normal speeds unless you're using like a fast resin, specifically designed for those really, really crazy fast speeds. But most of your normal resin, you're gonna wanna use the normal setting, at least from my experience. And you also notice that we have wait before print and wait after print. There's no wait after lift. Because there's no lift, it doesn't make sense to be there. All right, and I think that about covers it for this one. If you could please, in the comments below, let me know if for this particular video I went too fast, if there was something I didn't explain well enough. I really want to make sure these videos are accessible for all of our new users as well as our very experienced users. If you could, please like and subscribe to this video and to our YouTube channel. It helps out a lot for me to continue making content like this. Now also, if you have any questions, you can also follow us or reach out to me on our Lychee Slicer Discord. And as always, thank you for watching and have a good day.